All right, translations and dilations. So here we have that if you have the function y minus k equals f of x minus h, that k and h values are going to be its uh, horizontal for h and k for being vertical. And typically you'll see that in class I usually don't use k. I'll use v just to remind us. So it's horizontal is h and vertical is v. But I will go ahead and refer to it as k throughout the rest of the video. So um, if we're going to translate a periodic function, or really any function, but we'll use the periodic function right now. This is our guide. If we're going to translate it horizontally and vertically, and translate means just kind of move, if we move it left or right or up and down, and we're going to do so through adding either a h value or a v value. And so let's go ahead and take a look at that. Here again is our graph of sine equals, or y equals sine of x, or f of x equals sine of x. And this is a function that we're going to spend a lot of time with in the future. But right now I'm just going to refer to it very basically. Here it is. It's a sine wave. And now if I want to move this whole graph, this whole function vertically, if I want to move it up or down, then I'll add a k value, and remember it was y minus k. And we typically would see this, and hopefully you recall this with a parabola as well. If you have a plus 2 at the end of it, it raises all of it too. If you have a minus 2, it raises or drops it all too. And so I've gone ahead and graphed it. This was a with a minus 2, and so g of x equals sine of x minus 2, and here we are. So it's all dropped down from the original function. The whole function's dropped down 2, and that's with a k value. So let's go back to our notes here. To be more explicit about this part right here, we are much more used to seeing this, and really how you will see it is that y is equal to f of x minus h, and that h, you typically are going to do the opposite. We'll talk about that in just a second. And your plus k value, or plus v value. So we had a positive v, a negative 2v, so that means everything dropped down 2 here in our translation. All right, next graph, we've got the sine of, and then inside the parentheses, x plus 1. So that x value has 1 added to it every time before it gets put through the function. And so if we think about it in terms of h and k, this will be a minus h. And so minus a negative 1 h. And so look what's happened. Everything from the first function has been moved to the left. Where we had x plus 1, that means our h value was a negative 1. And so everything happened negative 1 earlier in the graph. It happened 1 earlier in the graph. Whatever the y value was going to be over here, it happened at the x value that was 1 less, because we have a negative h. Those are horizontal and vertical translations. Now, dilation is going to be a little bit different. Dilation is going to be that, looking back at our notes here. Now, if we dilate, notice that we're going to multiply the result by c. So our y value gets multiplied by c. And if you're going to guess what that might look like, right now would be a great time to pause it and try to figure out, hey, what would happen if I multiplied all my values by c? And here's the result, or by 3 as a c value. And here's the result. Notice that the period is the exact same. The fundamental period is the exact same. It's the same length. The crest of the waves still happen at the same time. The troughs of the waves are still happening at the same time. All that's changed is its amplitude, where before the amplitude was 1, because it went up 1 or down 1, kind of from that midline. Now it's going either up 3 or down 3. If we took our maximum value of 3 minus our minimum value of negative 3, would give us 6. 6 divided by 2 gives us 3, and our amplitude here is 3. So if we want to change that to 1/2, for example. So 1 divided by 2, and graph that. Notice that it made it much more mellow. It's not, the amplitude is far lower now. So our maximum of half minus negative half gives us a 1. Divide that in half, and we have a amplitude of a half here. All right. Last, we're going to go through and dilate horizontally. And so here with the first one, we multiplied the result, our output, by a value. Now we're going to multiply our x value, multiply our input by a value. Notice what it says is going to happen. It says it's going to give us, the inverse is going to give us 1 over c. And let's take a look at that. So if we have, here again is the sine function, and this time we've typed in sine of 2x. So as we plug in that x value, we've multiplied it by 2. Let's take a look at that graph. What's happened here is that it's been compressed, and where before it was roughly 1, 2, 3, 4, 5, 6.5 spaces for that period to be to repeat. Now it's only 1, 2, 3 from about crest to crest is roughly 3 units, because we have doubled the x value, so the input happened twice as frequently essentially, and so everything's happening twice as frequently here on our graph. So hope that gives you just kind of a visual help of what's happening here with our translations and dilations.